Okay, welcome to week 4, and today we continue on with our progress. Now, I'm going to start off again with our white exact values trig to help emphasize how important this is. Okay, so 2, 2, 2. These angles all equal because they're the same side of triangle, and so 60 degrees, and that means it's the bigger angle, so it has the smaller denominator. Now, if we take this triangle and bisect this triangle, and that means that we're going to halve this angle at the top and halve the length of the sides. That'll mean that we'll have a 1 there, 2 there. This will still be 60 degrees, pi on 3, but this angle here has now been halved. So it's 30 degrees. So the smaller angle has the larger denominator. So what we have here now is a triangle that has particular sides, particular proportions, and particular angles. And that's the thing that I'm asking you to develop a sense of what those proportions, angles, and the like are for, to help you in your development as you move into the next subject. This will be needed for all 4 unit work. So what we want to do is work out x, and so what we'll do is we'll take the Paddock idea and we'll make a square, and the square will represent the hypotenuse, which has a side of 2. So next to that then will be our right-angled development, and so on the right-angled development we'll have the side of 1. Side of 1. And over here we'll have a side of x, the unknown. So what we know from Pythagorean theorem is that using this geometric interpretation it does take for students. So if we add both the paddocks of the siblings, the other sibling, the sibling that's got the big one, it's equal to those. So that's our geometric interpretation of Pythagoras. So what we want to do then is do the algebra of this. So we've got 1 squared plus x squared is equal to 2 squared, and then we do a simple undo, and we get x squared is equal to 2 squared minus 1 squared, just keeping the numbers at the moment, and then taking the square root, and then we can think about changing the numbers back again. What's the maths of this? It's that old chestnut, isn't it? X squared and a half. When you multiply those, you get 1. Okay, so I've kind of missed a few steps there. So down here we'll get 4 minus 1, which is the square root of 3. Okay, so x is the square root of 3. Alright, so we're nearly there in terms of our development. What we want to do is take this right angle triangle, which we've now found, to have these properties. A hypotenuse of 2, the short side of 1, the long side of root 3. The angles are not changing. The smaller angle has the larger denominator. The larger angle has the smaller denominator. And so what we're going to do is divide by 2. This has the effect of putting us into a single unit hypotenuse. A single unit hypotenuse is valuable to us because it allows us to place the triangle on a unit circle. Now this is a different way of teaching unit circles. The all stations to Canberra, or all stations to Central, or all stations to Cronulla, or whatever it is that you have experienced in the past, relies on adding of fractions, and that's a different paradigm. This is just a simple recognition process that I'm trying to get you to develop. Okay, so hence the ask to get you to do this from a blank space, just as I'm doing it, and arrive at these proportions and these angles. So here we've got pi on 6, a smaller angle. The larger angle has the smaller denominator, and that is our goal. Our goal was to get that one out. Okay, we can use this one, and we've also got another one which I don't do the development for, which relies on both of these being the same, and again hypotenuse, and 1 over root 2, 1 over root 2, and these angles are the same, and that is 45 degrees, and that is pi on 4. So registering in your mindset those two triangles takes an enormous burden off you when you move forward in more advanced work. So that's kind of like part 1. I've been doing that now for a few weeks, trying to get the importance of that for you so that you understand how important it is. Now these triangles can appear on the unit circle. So if I draw the base of that, what we'll have is 0, then we'll have a length of 1, a length of 1 positive up here, but this is a length of -1 and a length of -1. Then as we go up, we'll go to pi on 2, and this is pi on 180 degrees, and then this is 3 lots of pi on 2, and then this is 2 pi as we come back in. Okay, now we can do this in the red just to show you that it can be negative. So we can start at 0 here and head off this way, and we'll get minus pi on 2, minus pi, minus 3 lots of pi on 2, and minus 2 pi. Now, don't worry about the minuses at this point. It's just you haven't learned the counting method that I want. So when we learn the counting, that'll make sense. All right, so in this place here, what I'm just establishing, repeating everything that's over here for this one, repeating all of that information, and assuming that you see in your Maths DI this particular pair. So everything that's in this one over here, that's your Maths DI. Okay, that's what you're seeing every time you look at these. Now, in terms of the orientation, these particular, they can sit like that, they could sit up like that, they could sit like this, or indeed they could sit that way, or we could put any combination of the rotations. Here, this one here, we've got the 45 degree happening, like y equals x on the hypotenuse. And all that's happening is that it's appearing in different locations around the wheel. And so often you see it when it's connected together with all of them on there. And so it's important that you get a sense of what's going on with that. So that's the 45 degree one. This is the 60 degree one. And so they're all being kind of superimposed. And so you get a sense of all the proportions. And they fully represent by these two. Okay? So this is a really big and important diagram in the sense that you're taking all of this information here and thinking about how these triangles are sitting on it, and then using your knowledge of that to build up a response to problems. So let's have a look at some further ideas that help us consolidate this. So this would be part 2. And so for part 2, what we want to consider is 3 things. We want an association, and we haven't done this, you may not have done this before. We also want a proportion, and I've talked a little bit about the sizes. And also we want to know if something's plus or minus. And it'll become apparent as we go forward what that looks like. Now, the way that we do this is that we think about this from a SOHCAHTOA. So this is going right back to like year 8. Okay, so what we're doing here is we're putting up our triangle, and on Cartesian coordinates, we can think about them in terms of y and x. We don't normally do that for these guys, but for here we can do that. And if we've got a unit circle of 1, okay, not worried about the angles for this one, but we can do sine. So if we do sine of this angle here, sine of theta is opposite over hypotenuse, so y over 1. Oh, now we don't normally write it as y over 1, so we can write it as y. The big idea there is sine theta is now a new version on the unit circle. What's another name for y? Sine. What's another name for sine theta? Y. So we use this association to interchange them one for the other. So cos theta, ca, now we're using adjacent over hypotenuse. So we go ca at x over 1. So we don't normally write things with, we don't write the number 77 over 1, we just write 77. Okay? you can do it when it's necessary, but we don't want to do that. We want that to be an idea that sticks in our head, that we've got a new association on a unit circle for cos theta being x. And if we've got cos theta being x, it'll help us tremendously as we unpack these ideas. All right, so that's our association idea, big idea. The next thing is proportion. So we want long side, short side, long, short, okay, and just plus or minus. We want to understand the quadrant. And we do that with reference to this guy up here. You can see that some of the values are minus and some of them are positive. Okay? So positive, positive, negative, negative. So that's all that's referring to. So with these three ideas, you can conquer what is a very complicated set of ideas in mathematics. All right, so just keeping to my mantra about the time and all the rest of it. So if I take this guy here now and just do a Pythagorean, I could do the whole picture and all the rest of it for you, but that's not really my point. If I'm doing it the algebra, I would get 1 is equal to x squared, 1 squared is equal to x squared plus y squared, 1 is equal to x squared plus y squared. Now, what's a new name for x? So we're going to use these associations to populate this in equivalent sense. Okay, so 1 is equal to cos squared. Now I'm just going to put brackets because any variable can go in there, and y is sine squared. Wow. So it could be theta. It could in fact be x and y, which is often very confusing for students. But if you just get the concept that the variable can go in as needed, here we've got this new arrangement that we've made, replacing x with y. All right, so if we divide by cos squared, this one, we will get 1 over cos squared equals cos squared over cos squared plus sine squared over cos squared. And so it's not long before we get to a point where we can say, so cos over cos is cos squared over cos squared is 1. Sine is y. Oh, that's rise over run. That's rise over run. That's m. And we've also learned that it's tan. Okay? So tan theta. So because they're squares, it's going to be tan squared theta. And over here, I just use this one, cos. 1 over cos is sec. So you just use that one as a sec squared. So that's a new relationship. And it has the other form, of course. If we put 1 as the front runner, we'd have sec squared minus tan squared as an undo. Wow. So we've got lots of things that we can substitute 1 for, and just recognising these is a huge deal. Okay? Just recognise them is a huge deal. So this is where these things come from, and I'm just showing you this because although this is not the emphasis is on this stuff up here, I needed to show you how this pulls apart. Now, if we do divide by sine squared, we'll get 1 over sine squared, and we'll get cos squared over sine squared, because we're dividing through by sine squared, and we've got sine squared over sine squared. And so that one is 1, isn't it? 1 over sec is cosec. So sec is just cos, that's how I remember it. And you can remember it any way you like. Cosec, that's the sine one. Cosec squared. And then cos over sec, sine is the upside down of tan, which is cot. So what we've got is cot. Okay, so this is our next development, and from that we can again write one in terms of the others. And so we've got these weapons that we can use for substitution. So they're the substitution ideas. Okay, not really big on that. the exact values trig ideas are up here, okay? Now we're going to use those now to help us with that. So the sub-ideas are good, they're helpful, but they're not the whole thing. The whole thing is that we get a sense of how to use our exact values trig ideas. So let's do that. A typical extension 1 topic from school would say for theta is given as 0 to 2 pi. Now that can change, of course. Find sine theta is equal to -1/2 and cos theta is equal to √3/2. So there straight away our recognition kicks in, and we've got the 3 ideas. The 3 ideas from exact values trig. So we look for the association. What's the association? Well, we've got a y is equal to -1/2, and we've got an x is equal to √3/2. We've got a y which is 1/2. Now 1/2 is less than √3/2, so this one is smaller, and this one is larger as a proportion. So that's the proportion idea. So we've got association, proportion, and then the plus or minus. This is a negative, and this is a positive. So those 3 ideas have been nailed for both terms. We've got a small negative y, a large positive x. So the way the process is, step 1, you have your unit circle with all of the incumbent bits on it. And so we start at the origin and we do x first, okay? So step 1 and then step 2, nose to tail. So we do step 1, it's a large positive. There we go. That's a large positive. So that side there is √3/2. Now that's a little bit less than 1. It's about 0.866, so it's a little bit less than 1. Then we go to the end and we've got to decide with y, do we go up or down? Up or down? Well, it's a negative, so we're going to go down, and it's a short one. So what we've done is we've drawn a triangle that sits inside our one wagon wheel. It's one of these guys. There it is. It's one of those guys, and it happens to be this one right down the bottom here. So we need a method of just checking what the angle is. Now the step number 3 is what is the base angle? So the base angle would be the theta. Now watch this carefully because I'm going to put in theta is equal to, now what would it be? It's the small angle. Now you notice I'm not writing anything, I'm speaking to it. I'm expecting you to do it out of your head. The angle is the smaller angle, and the smaller angle has the bigger denominator. Now look what I'm going to do here carefully. I'm going to leave a gap. So I'm going to put pi, the smaller angle has the bigger denominator. Now it's some count. So what I'm going to do is I'm going to put all the potential triangles of 30, 60, 90, 120, 150, 180, all the way around. Now not all the triangles count every axis, and we'll see that when we do a 60-degree one next week. But for this one here, what I need to do is count. So all I'll do is count. So I'm starting off here. Okay, you ready? I'm starting at 0 and I'm counting. So I'm going to count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So to get to the angle, I went all the way around 11 lots of 30. 11. Now, how easy was that? That's fantastic. Okay? Now, 11 lots of pi on 6. Now, if you put your calculator in and do sine 11 lots of pi on 6, we'll quickly do that just so that you can see it. So we've got, and make sure you're in radians, and we'll go sine. So I'm going to put 11 pi on 6 in the 11 times pi divided by 6 equals, I'm going to put that in the memory recall, because I'm going to go to my trig functions. I'm going to go to sine, Ooh, negative 0.5. Wow. Negative 0.5. So it's a tick. That matches that one. Tick. Okay. Let's do it again. Let's get out our memory recall. Okay, memory recall. Let's do cos this time. Cos that, please. 11 pi on 6. 0.866. 0.866. It is. Okay, check it for me. Let me just do that for you. 0.866. We'll go along like this. So let's just do it. So we're going to go here. We're going to go 3, the square root of 3, divided by 2. That's the same number. So it's correct. The number was correct. Okay, so using that, we can do that. All right, the other thing I'll quickly show you here, because I'm going to wrap this video up, is we'll do different triangles next week, just to get you in the mood for it. But this time I'm going to go one count negative. So I'm going to go minus 1 count pi on 6. So it's just pi on 6, because I would normally put a 1 in there. I only had to count once. So let's try that again. 1 lot of pi on 6, but negative. Okay, so we'll clear all the noise away. Clear our memory out. Clear this out. And what we now is a blank calculator. So what we're going to do is minus pi on 6. So pi divided by 6 is equal to, now we'll make that a minus. That's our new value that we're going to check sine and cos against. So let's put it in the memory. We've still got it sitting there, so I can go and get my, is this right? Oh, ta-da, tick for the red one. So whether you go around the wagon wheel anti-clockwise or whether you go clockwise is irrelevant. You've just got to have the right polarity, plus or minus. So you're counting negatives or you're counting positives. And I'll do some more examples as time goes on so that you get a use of that. Okay, so if I just clear that away and pull back the memory, and I want to check cos, so I'm still in radians and going hit cos, there's that number, 0.866 positive, that's root 3 on 2. So the red one gets a tick as well. Okay, so this is a concept, an idea, and it's something that it's the quickest way for us to digest what's happening with our particular parts. All right, I'll come back and we'll have a look at the classroom development of E and Ln. See you next time.